Cycle 2, Lesson 1. So this is the first lesson, obviously, of Cycle 2. And in this cycle, we're going to look particularly at applications of various functions that we began with in Cycle 1. So in Cycle 1, we looked at polynomial functions, rational functions, exponential functions, trigonometric functions. Now we're going to circle back and look at them again, but this time we're going to look at things like applications, and rates of change as well is also going to show up in this cycle. So today, since we started with polynomials in Cycle 1, we're going back to polynomials at the start of Cycle 2 again. And we're going to look at how we can use technology, graphs, Desmos in particular, to help us solve applications involving polynomials. So we just have one question today in this lesson, and here it is. Based on research, the marketing team at Best of You predicts that when the price of a bottle of a new SPF 50 sunscreen is X dollars, the number D in hundreds of bottles sold per month can be modeled by the function d at x equals negative x cubed plus 8x squared plus 9x plus 100. So the number of bottles sold in hundreds is a function of how much they charge. If you charge more, presumably you're going to not sell as many. So let's graph the function anyway, and then take a look at what it looks like. So d at x, so I need to go to Desmos and then type this in. I'm going to do it right from scratch so that you can really see how I would approach this. I don't need to call it d at x, I can still just call it y. Y equals negative x cubed plus 8x squared, I think it was, minus 9x, I could be wrong on the sign there, I can go back and change those, plus 100. Let me just double check those signs though. The signs went minus, plus, plus, plus. They're all pluses except for the first one, so let me just change this to a plus as well. And let me make this projector mode. And okay, so I've graphed the function. The first thing you might notice is that we can't actually see the function anywhere. So if that's the case, don't assume you did something wrong. Try zooming out, and there's the function. It's just that it was off our screen. But we still have kind of a problem here because we can't see it super well. So maybe what we could do is we could adjust the x-axis. Why don't we just start at 0 for the x-axis? And it looks like if 100 is, I can see 100 on the scale here, so if every block is about 20 units, it looks like if I make the upper limit of my x-axis 10, they should fit on there. And it does. So here's the graph. In fact, I can actually zoom in a little bit now that I've tweaked it, and I can see everything. I can see the graph, I can see the y-axis, I can see the x-axis. And what we want to know is, for this function, the domain. Well, this function goes on forever in all directions. I don't want to mess it up by changing the scale again, but it does go on forever. It goes from quadrant, it's a cubic, degree 3 with a negative leading coefficient, so it goes from quadrant 2 down to quadrant 4. So technically the domain is all real numbers, but because we're dealing with a application now that it doesn't make sense to get into certain sets of numbers, we're going to restrict it. The first thing it doesn't make sense to do is to go below 0 on the x-axis. If we were to go below 0 on the x-axis, that would mean that we'd be selling negative bottles of, sorry, not selling negative, x was the price in dollars. So we'd be charging negative dollars for the sunscreen. So if I went to the drugstore and picked up a bottle at, say, where it said negative 0.513 as max value, they'd give me 51 cents for every bottle I picked up. They're not going to do that. So it doesn't make sense to go below 0 for the price. Nor does it really make sense to go beyond the x-intercept here of $9.92, because once you get past that, you get into negative sales. What does that mean? What's a negative sale? Are people returning it? I don't even have an explanation for that. So hopefully it's clear that we need to stop at the x-intercept as well. So the domain is really just going to be between these two values, between 0 on the x-axis and 9.92. So maybe I'll take a picture of that, and then I can insert it into our OneNote so that we have it for reference. Okay, there it is. Didn't mean to do that, it's disappeared. I'll bring it back. Alright, I'll leave it like that. Alright, so there it is. And we will write our domain now. D, no, that's an X. D equals XER. X is a member of the set of real numbers, where X is greater than or equal to 0, less than or equal to 9.92. I'll round it to 2 decimal places because that rounds it to the nearest penny. So there's our domain, and that's our answer to part A. How many bottles are sold per month when the price of each bottle is $5? Okay, we can still use our graph to help us answer that. $5, we can see on the graph that it's somewhere around 219. A nice way, an easy way to get that answer though is I can just put a vertical line in there. If I say X equals 5 for $5, it creates a vertical line, and then I can clearly see what the point of intersection is. X is $5 and Y is 220, and that would be our unit sold. Now remember that 220 is hundreds, so we have to add a couple zeros to the end, so it would actually be 22,000 bottles sold. Okay, that seems to fit fairly nicely. And so the answer, 2,200, or we could just call it, oh sorry, not 2,200, 220 hundreds, or 22,000 bottles sold. When the price is $5 a bottle. Part C. Determine the value or values of X that will result in sales of 17,200 bottles of sunscreen per month. Interpret the answer. All right, back to the graph. Again, we're going to be using Desmos and graphs a lot in this unit as well, so hopefully you feel comfortable with it after last unit. Now this time we want to know when it's at 172 on the scale. So we can see that the highest it goes to is 226. We want 172. So that's somewhere around here. But again, we can just get Desmos to do the work for us. If we say y equals 172, then it puts a horizontal line in there and find the points of intersection again. Notice that there's 2 points of intersection in this case. Both of them have y values of 172. One of them is at 3, and the other one is at 8. So the way we interpret that is they'll sell 17,200 bottles if the price is $3, but they'll also sell 17,200 bottles if the price is $8. So we have multiple answers, and that makes sense. You can see from the graph that they'll sell more bottles for somewhere in between. So at around $6 or $5.75 maybe, that's where they sell the maximum. That's not one of the questions, but if that was a question, we could certainly answer it. If I want to find out what price gives me the maximum sales, then it would be $5.85 per bottle. So again, we can use Desmos, we can play around with it, and it can really deliver up a lot of information to us, getting familiar with the graph.